What's good in the hood, guys? Welcome back to Ms. Leg's YouTube channel. Today we're going to be learning about functions.
Linear functions.
Woo!
That's my trick. I get everybody to clap and then I pretend the applause is for me. Thank you guys. Thank you so much. Thanks for coming out today. Thanks for watching. All right, here we go.
Yes, sir.
We're going straight into the examples now. We just did a little activity where we worked with a function, a little machine where you have an input and then you get an output, right? So we are going to go into our examples. We need our notebooks open. At the top, it should say lesson 3.2. We are only going to go through about half of the examples from this lesson. We'll finish it on Monday. And just a reminder that your homework is assigned tonight, but it's not due until Tuesday. On Tuesday, I will have a video up that helps you through the homework for anything that you had trouble with over the weekend, okay? It's not a lot of questions, and I made them on the simpler side, okay? So, how can you identify a linear function? What does linear mean?
A straight line.
Yeah, a line, right? It's literally in the word, linear, okay? So a linear function is like a machine that causes the relationship of the input and the output to have a steady line, also known as having a slope, a consistent slope, right? That's a big part of being a linear function, right, is to have a slope. So now we're going to evaluate functions in function notation. Now, remember how we talked about voice in the back, silence. Remember how we talked about notation yesterday? We talked about set builder notation, okay? That was just a fancy word. Notation was a fancy word for the way we write. I see some people going like this. Yes, it's a fancy way for the way we write something. So today we're going to talk about how to write a function in a fancy way. It's going to look weird, but it's not that strange. It's just a way of writing it. So how can you represent a function rule? Okay, we decided that the rule of the function that we just worked with was eventually that machine is simply just multiplying that number times 2, right? It's doing a bunch of little things to it inside the machine, but when it comes out, it's twice as big as it was before, or twice the number that it was before. How can you represent that function rule? So now we're going to start with a simple linear equation. So this equation, y equals 5x plus 1, we're writing this down. Y equals 5x plus 1. We're going to write it using function notation. It's going to look almost exactly the same. Remember yesterday when we went from writing an inequality to set builder notation, and it pretty much looked exactly the same because the inequality was part of it and just had a little bit fancier notation on top of that. So a function is the rule that takes the input, which is also the domain, or the x value, right? The input, or the element in the domain, which is your x value, and it maps it to an output. Mapping it just meaning showing how it goes from the input to the output. It maps it, it connects them, it shows the relationship. Yes?
The picture on the bottom, it looks like a factory.
It does look like a factory, and that's why we like to call functions machines, because if you think of a factory, it's pretty much one big machine or full of certain machines that if you think of like, I don't know, what factory can you think of, like something that makes something, like Coca-Cola, right?
You know what?
Okay, in the Coca-Cola factory, when you put in the ingredients, what comes out?
Coca-Cola.
Coca-Cola. right? When you put the Coca-Cola, like, has anybody ever had glass bottle Cokes? They're
Yes,
so much
yes.
better than every other Coke you can get.
I have a glass
Okay, you
bottle
put
collection.
the glass bottle into the machine and out comes a nice, perfectly filled, fizzly Coke that we always get on Thanksgiving. It's like a special treat, even though they're so much more expensive than all other Cokes. We get glass bottle Cokes on Thanksgiving. It's just our thing.
Miss Lee, doesn't f of x equal 1?
Yes. Do I even need to teach this lesson, or you guys already know everything?
No, I saw it on Instagram.
You saw it on Instagram. That is the best
We
thing
should
I've
just
ever
learn from
heard that
Instagram.
somebody saw on Instagram. Usually, what you see on Instagram is not relevant to learning.
Oh.
But if you saw that on Instagram, whatever channel that is, keep watching it, okay? So function, so we're mapping it to an output or the range, which is our y value, our output, and our range is also our y value, okay? So we're taking an input or our x, which is an element in the domain, and we're mapping it to the output or what we call the element in the range, which we also know affectionately as y, because we've been working with x and y since probably 5th grade when you started learning about the coordinate plane, maybe even 4th grade, I don't know. And so we've always known them as x and y, but now that we're getting into really like the relationship between x and y, we have the fancier names, like the input and the output, and the domain and the range, okay? Function notation, vocabulary word here, you write it down. Function notation is simply a method for writing variables as a function of other variables. Now that sounds like, what does that definition even mean? It's because it's so simple that it's hard to describe it. It's basically saying that you're writing it so that you're showing the relationship between your variable x and your variable y. Although, just like Ryan saw on Instagram apparently, when you're writing it in function notation, a linear equation like this, y equals 5x plus 1, is actually going to be written like this. F of x equals 5x plus 1. So this is the equation as a linear equation. This is called a linear function. It's the exact same thing. Same relationship, same machine, but we are replacing y with this fancy little f parentheses x parentheses. And it just means the function of x, meaning once you put something in for x, out is going to be your output, which is what happened. This is saying, well, the function of x, what happened to x, comes out here. Yes?
So it's basically the same thing as before, but instead of putting a y, we have x parentheses f.
F, yeah, and the way we say it when we're reading that notation is f of x. Does that say it on this side? I think it might say it on the next slide. But
No, it
this,
says it right there,
where?
at the very bottom.
Yes. F x is read f of x, meaning the function of your x value is what you're going to end up with. Once you put it into that machine, out comes whatever it did to it.
So do we solve
Your
it the same
output.
way?
Yep. Okay, so here's our little machine here. And what's happening is you have your input, which is our x value, right? It goes into the machine. It is being multiplied by 5, and then 1 is being added to that product. And out comes your, what you might call an answer, but in fancy terms, we're gonna call it f of x. It's the same thing as y, it's the same thing as the output. Same thing as the range. So now we've kind of got another little synonym for our range, our y, our output. Now it's the function of x. Does that make sense?
Where did it come from?
Does it kind of make sense? It's the same thing, just written in a different way. That's why it's called function notation, the way we write a function. This is kind of important over here. Function names are not restricted to the letter F. Obviously, they chose F as the most standard way to write a function of X because function begins with F. But you can use other letter names, like, so I could do the what am I writing? I could do the function of X, and that can represent a certain function, right? You can also use any other letter depending on, maybe you're working with a situation where you are writing a few different functions. You don't want to call them all the same thing. So you might call it G of X. You might call it H of X. They are still all representing functions. It just depends on what you're working with. You might want to use different for multiple situations, yeah.
It says functions one.
What?
Functions one.
Functions one?
Functions
No,
one.
Or in the representing contact, it says letter names to functions when. There's no space between functions and when.
Oh, thank you. Can you screenshot that?
Yes,
Yep, was that Gavin?
oh,
Okay. All right, moving on. This is a lesson that I might go ahead and teach over 3 days. We'll see. Because we're still on example 1, is the second part. Now we've got the same function. Oh, look, they decided to change the name from f of x to what?
G of X.
G of x. Does that mean it's a different type of thing? We have to solve it differently? No, they're actually using the same function as here, 5x plus 1, but now they're calling it g of x. It's the same exact thing. Yes?
What is inquisitive to them? It didn't have a growth mindset.
In what ways can you be inquisitive and open to learning new things? What word do you think of when you think of the word inquisitive? And I am thinking of a verb. So I'm not asking for a synonym, I'm asking for another word that comes from that same root, but it's a verb, to blank. If I want to blank about something.
Oh, quiz.
Okay, it comes from these first 5 letters.
Inquire.
Inquire, very good.
Yes, sir.
What does it mean to inquire about something?
Game.
To ask about something. To ask for more information. So it says, in what ways can you be inquisitive and open to learn new things? Ryan did it. He watched an Instagram about functions. Yes, and that is the kind of Instagram channel you should be watching. Okay?
Callie, you don't.
There's also a really cool YouTube video with the best math teacher in the whole world, and that's another social media that you can watch. It's called Mrs. Leg Was Here with a UZ. Okay? And just so you know, I'm not the best math teacher in the whole world, but
There you are.
I'm
you are.
Are you
All right.
sure?
Okay. So now we're going to say, what is the value of g of x equals 5x plus 1? And we can keep in mind that that really simply means y equals 5x plus 1. Because y also means the output, right? Or the range. So if we evaluate that and it says when x equals 3, what do we do with that 3?
Replace it for x.
Yeah. Plug it in, plug it in. You know those commercials that the
That's what
plug
my
in
dad
makes the
says
room
every
smell
day.
good? Well, we're gonna plug it in, plug it in. If it says x equals 3, then we'll take take that 3 and substitute it for x, or plug it in. And it's actually really simple. They're gonna take that 3, put it into this function machine, and when the 3 gets replaced, or the x gets replaced with 3, we multiply 5 times 3, and we add 1, and what comes out, our output is 16. Yes. So, our input was 3, our output was 16. The way that we would write that, if we're looking for the function of x, or g of x, when x is 3, we're simply going to write the answer as when g, if you're putting the function of 3, meaning 3 is going into the machine, what's going to come out is 16. So this is how you would write your answer. Does that make sense?
Yeah.
Good. I love how this is all making sense. You guys are going to try it on
Yes,
your
Why
own.
don't you give us a harder one?
It's not harder.
There's Nicholas, that makes it harder.
You guys can do this silently on your own. Make sure you write your answer in the correct notation. For example, once you plug that 4 into your x value here, you're going to write g of 4 equals whatever that output was, okay? For your h, you're going to write h of 4 equals whatever that output was. So when I come around, I don't want to just see a number answer. I want to see g of 4 equals blah, blah, blah. H of 4 equals blah, blah, blah. Go ahead and solve.
Do we have to solve this algebraically?
No, because you're not trying to isolate a variable. The variable is being substituted. Huh? You say I don't know how to do this?
Yeah.
Okay.
I forgot how to do it.
You're just pretending to not know how to do it because
Can
you
you
just
go
want
back?
I just
Oh,
wanna
I
see-
see why I do this.
I just want to see Jerry.
You got this.
Look,
when
Carmen,
you come back,
we-
again, try these
remember,
first.
we're not just telling stories, we're telling lies.
Yeah, don't forget to use your order of operations.
If x equals 4, what do you
You can.
If x equals 2, number is
Yeah.
What's
Yeah.
up, Carmen? Remember, we're not just telling stories, we're changing lives.
No, do your work. When you get the answers right, you can go to the bathroom.
x equals 4. Yeah.
Are you done?
No, in
Okay. Does anybody need help getting started on these? No? Okay.
yo soy.
Maybe 7 times 4.
Okay.
The 2.
So,
Oh, okay.
It says
negative 8.
evaluate the function for
And then
x
minus
equals
3.
4, meaning solve
No,
this,
shut up.
but replace x
Well, you
with
don't
the
have to write
number
x
4.
anymore. You can
Oh.
just
And
do
then
it.
get your answer.
Okay.
You got
Yes,
it?
uh,
Would it be 11?
Yep, negative 11.
Okay.
yes, I finished.
No.
This is correct, this is not. Let's see what you do. So
Unless
did
you
you
want
do
it.
it?
Oh, you're trying to check your next answers? I don't
I
want
just wanted to see you, Jerry. That's all.
Minus 3. Correct.
You can simplify that. Maybe we can minus 3.
So you have to actually still evaluate this.
Negative 11, nice. Okay.
Perfect.
That's just your answer.
Easiest math lesson ever.
I finished.
So I'm gonna have to continue
Was there a question?
Because why did you kill this cockroach? This is a negative 2.
Because I don't know.
Because you don't like cockroaches? I don't like cockroaches either, but you only kill a cockroach, guys, if you are subtracting, okay? You don't kill any cockroaches if you're multiplying. The cockroaches can live if you're multiplying. Yes, you got this one right. Where's the other one? That is not correct. So what'd you get here? Okay, so this, you have to write this down. You get negative 8 minus 3. So you're skip. Guys, if you're not showing all your work, you're trying to do it in your head and you're messing up, it should send you a message that you should not be doing it in your head.
Yeah, that's
If you're multiplying two numbers, write that number down. Write down the product.
Just say Jerry.
Very good.
Yes, sir.
Giant green Cheeto.
You're not funny, buddy.
43.
Okay,
Looks like I fixed it.
okay, good. So, does anybody want me to walk through these real quick? You get it? Okay,
Can
so,
you walk through them?
yes. So g of 4 would be -2 times 4 minus 3. A lot of you guys went, oh, -2 times 4 is -8, minus 3 is 5, or you did -5. I don't know why you did that. -2 times 4 is -8. Write that down. Don't do that in your head. -8 minus 3. Now, Aiden, here's where you kill that cockroach, okay? Kill that cockroach, change the sign, and you get -11 equals g of 4. And that's the way we write it in function notation. G of 4 equals -11. You get it?
What was the point of the cockroach if it was gonna be negative anyway?
It's negative because we killed the cockroach.
It was negative before though.
How is it negative before? No, it was subtracting a positive 3. It was subtracting a 3. So I killed the cockroach and changed the sign. Adding two negatives is easier than subtracting a negative and a positive. Okay, so that's the first one. You want me to go over the second one?
Sure.
Okay, so h of 4 would mean that I have to plug in a 4 for my x value. Now I solve 7 times 4 is? Anybody? What's 7 times 4? 28. Thank you. 28 plus 15 is what?
43.
43 equals h of 4. That's it.
Yes, you said this was gonna be hard.
I know.
You said it was gonna be hard.
It gets harder. This one's not that hard. Once we hit example 3, it's gonna get more challenging. This is like medium. This one's medium. I will probably only be able to get to this example. Then you guys will still be able to do your homework just based on these examples. And then we will finish this lesson on Monday, possibly Tuesday, okay? The cost to make bracelets is shown in the table. If she makes one bracelet, it costs $17. If she makes 2 bracelets, it costs $32. Which one of these categories sounds like the input, and which one sounds like the output?
Number of bracelets is the input, and the cost is the output.
Very good. The number of bracelets is your input, which is our x value. The cost is our output. Does that make sense? We're saying, I'm gonna put in this number of bracelets and see the cost, see what comes out into that machine, okay? So if you notice this x and y table, boys, if you notice this x and y table is horizontal, which is just weird. I don't like it, but that's the way they did it, so we're gonna get used to it, because guess what? Things on your test, things on the EOC, it might show your x and y table horizontally. So let's just work with it, yeah?
Why do you find that weird? I find that normal.
Yeah.
Well, that's wonderful. I guess I'm a little bit strange. I guess I'm a little bit more closed-minded. I guess I'm not as inquisitive and open-minded like the other slide said. Back to me, please. I have about 4 minutes, and if anybody tries to pack up before I give you permission, you will stay after class and not get a pass. I scare you to prepare you for life. Okay? I don't pack up and leave my staff meetings before they dismiss me. It's rude, okay? How can you determine the cost to make any number of bracelets? We have to find the function that's happening. We have to find what's going on. Now, this is going to be a little bit different, okay? We're actually going to be able to find the slope using these numbers, but in a little bit of a different way. It's still finding the change in y over the change in x, but watch this. Again, this is our x value and our y value. Why do I hear stuff that's not me? All I want to hear is me right now. I'm very, very egotistical. I want all the attention because it is for you to learn. Boys, here we go. we're going from 1 bracelet to 2 bracelets to 3 bracelets to 4 bracelets. Let's look at the change in the x. How is x changing from one input to the next?
So it's just going up 1.
Yep, it's just adding 1 every time. Now, how is the cost changing from one output to the next output to the next output? We're adding 15. So the change in the x is 1, the change in the y is 15. So the way we write that is always going to be our change in y over our change in x. So our change in y, even though it's on the bottom here, when we write our slope, which is always the change in y over the change in x, we write our y values, that change, 15. And the way it's changing in our x is 1. Same thing as just subtracting 32 minus 7. You know the slope formula, you subtract the second y value minus the first y value over the second x value minus the first x value. Same thing as the slope, we're just kind of doing it in a different way. And look, they're not calling it a slope here, that's so sad. They replaced the word slope with rate of change. Guess what? It means the same thing. A slope is a steady change according to the relationship. Aiden, can you please be careful? You are messing with my tripod. Okay? It is the same thing. So what is slope the same thing as? Rate of change, or change in the rate. Yes, very good. So our slope is 15 over 1, which we can say is 15. We can also call that m because it's our slope. Write a function using slope-intercept form. Oh, now they're talking about slope. So we need to know that the rate of change is our slope. When we write it, we're not going to write y equals mx plus b, because now we know that we can replace y with function of x equals mx plus b. All we're going to do is put our slope in there because that's all we know so far.
Yeah.
We also know that the relationship is linear because in order to make a line, it has to have a slope, a consistent change in your y over a consistent change in your x. That's what's making it linear. Give me 1 more minute and we will be done, okay? Nobody pack up, even if I go over. I don't care, I'll send an email out. Teachers do it all the time, okay? So we still have our x and y table over here. How can you determine the cost to make any number of bracelets? Well, we're going to use that function notation that we had. We had the function of x equals 15x plus b. So I can substitute. Remember, if this is my x and this is my y, I can use any x and y pair, my coordinate pair, to substitute my x and my y, which is now called f of x, substitute it, then I can solve that to solve for b, my y-intercept. So get this, solving for the y-intercept, now I have a full, perfect function that has everything I need to put any input of bracelets. If I want to make 100 bracelets, I just take 100, put it into the machine multiplies that 100 bracelets times 15, which would be 150. Come on, Lucian, right?
Yeah, come on, Lucian.
Come on,
Lucian.
Wait, stop! Lucian, correct me. I just said 100 times.
No, it's 1,500.
1,500, thank you.
Jesus.
Lucian, where are you going, Lucian? Okay. All right. I made that mistake on purpose to see if you were listening. That was a lie. 15 times 100 is 1,500. That's what the machine is doing. And then the machine has to add 2 because it's our... No, you stay right here. You don't pray to get out of my room, okay? You're staying
You're
out.
looking at me.
I don't
Yeah.
care.
You're looking at me.
This is important. Now, shush. The machine multiplies it times 15. Then the machine adds that y-intercept that we found too, and we get $1,502 it costs to make 100 bracelets. Do you see how functions actually help real life situations?
Yeah.
You want to start a bracelet business. You want to start your own jewelry company. You want to be the new, you want to be the new Jared, right? Remember?
No,
Jared.
Jared.
He went to right? Because Jared's that jewelry company, right? I knew that had to happen to you.
I love you, Jared.
We'll never record.
Are you guys ready to go?
Yeah.
Bye.
Make sure to like and subscribe, guys.
Can you press the card?
Later, nerds.